Welcome to Homework Lib.
Use Descartes' Rule of Signs to determine how many positive and how many negative real zeros the polynomial can have, and determine the possible total number of real zeros. So the number of positive zeros possible deals with a sign change. So notice we start with a positive term, then we change to negative, then we change to positive, then we change to negative, then we change to positive, then we change to negative, then we change to positive. That's 6 changes. But they could also come in imaginary pairs, so there could also be 4, 2, or none. The number of negatives, we have to think of p of x. I'm sorry, p of negative x for the negative. So if we substitute a negative x and raise it to an even power, the sign for the term is not going to change. But a negative to an odd power will change the sign, so that will become a positive x to the 5th. I'm just going to do it right over it now. And then a negative to the 4th will stay positive. A negative to the 3rd will become negative, but with a negative becomes positive. Squared will be positive minus a negative x will be positive, meaning we start positive and we never change, meaning it's not possible to have a negative 0 here. The number of real zeros possible in total, the maximum would be 6. But it could also be 4, 2, or none. List all the possible rational zeros given by the rational zeros theorem. All the possibles by the rational zero theorem says that it's the factors of the constant over the factors of the leading coefficient. Well, the factors of the constant are 2 and 1. Only 1 and 2 go into 2. Divided by the leading coefficient of the first term, which is 1. But it's also their positive or negatives. So it'd be positive or negative 1 over 1, which is 1, or positive or negative 2 over 1, which is 2. If you have to separate these out, it could be negative 2, negative 1, positive 1, and positive 2.